Now that we have learned about the core architecture, let's see how some of the popular DAS equipment manufacturers utilize them. There are a lot of different types of DAS platforms in the US market from a handful of manufacturers. This does not mean that there are not other manufacturers. I will just show in alphabetical order the platforms and manufacturers I have dealt with in the past. ADRF is an old repeater manufacturer which started DAS 2.0 platforms a few years ago. BTI is a relatively newcomer in the US compared to other manufacturers shown here. CommScope and Corning are giants in the industry, DAS industry, and holds a big part of the market share. JMA Wireless is relatively new in the DAS 2.0 field, but already has presence in big arenas such as Viking Stadium for Super Bowl 2018. Solid had been in the market for a while now, and already their DAS 2.0 platforms have been deployed in a lot of well-known venues. A big disclaimer for this slide: core architecture of the majority of the DAS 2.0 platforms are similar, although configuration, feature set, ease, and operation can be quite different from platform to platform. Now let's look at some of these DAS platforms, how they look. In a generic architecture, we saw a signal source feeding signal into RF interface unit through coaxial jumpers. In a solid platform, Solid Alliance Multi-Carrier, that's what MC stands for. In a solid platform, that RF interface unit is known as Base Station Interface Unit, or BIU. In the Corning, it's actually known as Radio Interface Unit, or RIU. In CommScope, the same thing is known as Point of Interface, or TPOI. So from the RF interface unit, RF is going into converter and distributor to be converted into optical signal. In solid platform, this converter and distributor is known as Optical Distribution Unit, or ODU. In Corning, it's known as Base Unit, or BU. And in CommScope, it's known as Optical Unit, or TFLN. From the converter through single mode fiber with SCAPC or LCAPC connector, the optical signal is going to remote, and the remote is converting that optical signal to RF signal to feed it into the antennas. Now this remote in solid is known as Remote Optical Unit, or ROU. In Corning, it's known as Remote Hub Unit, or RHU. And in CommScope, the same thing is known as Remote Unit, or TFAH. Now, as I have told you before, from remote, it converts optical signal to RF, and that feeds into the antenna. That's what I'm showing here. It's pretty much the same configuration through all the platforms. Now let's look at some real-life devices or electronics, how they look. So we're going to start with RF interface unit. In solid, this is the BIU. This is how it looks, base interface unit. In Corning, the same radio interface unit, or which we are calling RF interface unit. It's a little bit older model. CommScope, this is the TPOI. That's the card, and that goes into a chassis. We talked about RF to optical converter. In solid, those are called ODU, as you have seen in the last slide. In Corning, that's the base unit. In this particular case, it's called base 8 unit because it has 8 pairs of fiber connections. And then this is the TFLN for CommScope. Remotes in solid, we are showing 2 flavors of remotes, one with a 2 watt power output, the other one is with 5 watt. These are called remote optical unit. In Corning, this is the remote hub unit. This is how they look. And in CommScope, we call it TFAH, and I'm showing a wall mountable unit.